Okay, so let's get started. We're going to be taking a look at working with the basics of our idle control tuning capability found within our Link G5 and G4X systems. So this is going to be an overview of the idea of what idle control represents, what we're actually trying to accomplish here with the idle control. That's going to take us forward into the next few tutorials, taking a look at the different specific forms of idle control we have to work with. We're going to have a couple different options for programming capability. We have a mechanical-based idle control. This would be related to a cable-driven throttle body that does not have an idle control motor fitted to the intake manifold throttle body area. So we're controlling all of the airflow that comes into the engine through the throttle blade, and we're maintaining, controlling our idle speed through ignition timing. That's a mechanical-based idle control. Then we also have mechanical-based idle control, so cable-driven throttle body, but we're fitted with a idle control solenoid. And that's going to be a controlled vacuum leak. That's going to allow more or less airflow into the engine. They're typically used for cold start assistance. So cold engine, we have a high frictional drag on the engine, we have a torque loss. As a result, we need to bump up the idle torque to be able to maintain a reasonable idle speed. In order to do that, we feed the engine more air, and we do that through a controlled vacuum leak, which is the function of an idle control motor. Now, we have two types of idle control motors you might find yourself working with. We have a pulse width modulated style idle control solenoid. They're typically 2 or 3 wire in the control, and they're controlled with a pulse width modulated output. We also have an idle stepper motor. The idle stepper motor is going to typically have 4 wires for control, 2 wires to open it and 2 wires to close it. This is going to be typically found on a kind of a screw drive type of mechanism, and each time we turn that screw drive to open or close the idle control motor in a stepper style motor, it's going to be 1 step, and you might find that this total range of steps varies anywhere between 0 to 300, 350, really depends on the stepper motor that you're working with. The last option that we have for idle control would be drive-by-wire idle control. That's the absolute best way to control your idle, and just overall for operating your engine, drive-by-wire, in my opinion, is the way to go. Drive-by-wire obviously requires your whole vehicle to be set up for drive-by-wire control. So you're going to need an Excel pedal, you're going to need an electronic throttle body fitted to the intake manifold. So some engines will automatically come with this. Some vehicles will automatically have drive-by-wire control. You can retrofit drive-by-wire to pretty much any vehicle. So it's pretty simple to do that. We'll talk about those specifics in the drive-by-wire tutorials, setting everything up and then going through the idle control tuning for drive-by-wire. It's actually really, really easy to do it. But those are going to be the primary ways we have to control idle. Now, let's move from our basics page and let's go over here to our idle control specific page. We're going to move over into our idle page. This is where we do all of our idle programming. And if we could take a look, and I'm just going to do a basic overview here. So we're not going to get into the absolute specifics of how to tune the idle and all the specifics for a stepper motor or a pulse width modulated solenoid or drive-by-wire type of control. We're just looking at the bigger picture in this tutorial. So we can find here, if we go into the idle speed control setup, we're going to find a mode, and we can see here it's set to either open or close loop. This allows the Link to either look at the idle RPM, the desired target, and then try to match the output in the idle control routine that we're working with to get us to that target. So it can do that via spark timing, or it can do it via airflow. And we're going to break that down here in just a little bit. So it has the capability in the closed loop to self-adjust everything based on all of our parameters that we program in here. We also can do an open loop. Open loop is just going to use whatever we program in our base position table, and it'll run that for the airflow. If we're running an idle control motor or drive-by-wire, it's a really simplistic way to control the idle. So we have some options. We'll break this down a little bit further of what that represents. But if we move down here a little bit further, under the actuator type, there's couple choices we have to work with here. And as I was mentioning, is the options that we have for programming. We have none. None would be if you have no idle control motor or drive-by-wire. This would be mechanical-based idle control. So you have a throttle cable, you have your cable-driven throttle body, and you have no idle control motor at all. This is going to be what you'd select as none. Now, if you have a pulse width modulated style idle control solenoid, you'll select the solenoid option. You may find, and this is typically for a 2-wire pulse width modulated solenoid, some engines, OEMs, will be fitted with a 3-wire solenoid. And that is still a pulse width modulated control, but there's going to be pulse width modulated to open a flapper valve and a pulse width modulated to close a flapper valve in order to allow more or less airflow in. With a typical 2-wire solenoid, you can find these on Honda BD, H series engines. They're just going to be opening and closing a valve based on how much we're sending in duty cycle to the solenoid. We have a stepper motor. Stepper motor, as I described this before, it's typically 4 wires for control, 2 wires to open it, 2 wires to close it, and it is going to be essentially creating a controlled vacuum leak by rotating a screw mechanism either up or down by steps. And there's going to be total number of steps we have to specify. Different stepper motors have a different range of steps. So a GM idle stepper motor has about 310 steps, I believe. If you're talking about a Mitsubishi 4G63, they have about 150 steps. So we have to specify that for the link so it knows where it's tracking the stepper position in its movement, because things like as we shut the engine down and try to restart it, it has to understand where that stepper position goes to and tracks at so that it's going to deliver the same amount of airflow each time we start it. So there's a lot of specifics with the stepper motor. In my opinion, it's the worst way for idle control. A lot of inconsistencies with our stepper option. So you'll find this is something an OEM would have fit to the engine. So 1JZ, 2JZ engine, 4G63 engines, the older ones, will have a stepper motor. I always try to convert them to drive-by-wire. I just absolutely do not like stepper motors. Very problematic in trying to control them. Even setting up everything here correctly, they're problematic. Then we have our last option here, e-throttle. Again, I described that before. E-throttle is drive-by-wire. This is the best option for idle control, period. It's simple, it's easy to set up, and it gives you so much less headaches overall in getting consistent idle, whether the engine's cold or warm. Because there's stepper motors here, or the solenoid, these can get dirty, they can stick, they can create a hanging idle. You know, you have a mechanical aspect to dealing with a solenoid or a stepper motor that can be problematic. You eliminate all of that when you go e-throttle drive-by-wire. So these are the choices that we have. So hopefully this is very clear what we're working with here. So let's click cancel. Now there's all kinds of programming conditions we're going to talk about here in the next few training modules. So we have all of our speed lockouts or lockouts in general for RPM, throttle, map pressure. This is going to tell when the idle control should turn on or off. So normal driving, obviously we wouldn't have our idle control on. This is going to be some things we have to program and get into. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.